Hi guys, this is the 9th video from Math 9 ASI. Today we're going to continue our discussion on derivatives by looking at a couple other rules we can use, and we'll look a little bit at implicit equations and how we can differentiate those. So starting off, we have the product rule. So we have f and g, and they're going to be two differentiable functions on some open interval I. If we have that, then we know that f times g is also a differentiable function on I, and it's given by this equation. So the derivative of f of x times g of x is equal to f of x times the derivative of g of x plus the derivative of f of x times g of x. And we're going to use this identity every time, so it's really useful to have memorized. Just remember that we're going to have one function times the derivative of the other, and we're going to add the opposite combination that we did the first time. So the derivative of the other one times the function that wasn't the derivative before. And to go along with this, we have the quotient rule. So if f and g are differentiable functions on an open interval I, and g of x is not equal to 0 on I, because we can't have 0 in the denominator, then we have that f divided by g is differentiable on I as well, and it's given by this identity. So the derivative of f of x over g of x is equal to f prime of x times g of x minus f of x times g prime of x over g of x squared. Again, this is always going to work in general, so it's really handy to just know so you can whip it out at any time. To remember this, I like this little, I don't know what to really call it. It's just a nice way of memorizing it. You say low d high minus high d low all over the square of low. So here high is in reference to whatever our numerator is, and low is whatever our denominator is. And d means that we're taking the derivative. So we have low d high, so we have the lower function times the derivative of the higher function, minus high d low, so the numerator of the high function, times the derivative of the low function, or the denominator, all over the square of low, which is just a denominator squared, right? Hopefully that helps you guys. That always helped me remember it when I was learning this the first time. Here we have a couple of examples. Let's go ahead and go over those right now. So here we have our first example. Here we have h of x is equal to 6x cubed minus x times 10 minus 20x. You can do this in a couple different ways. You could just FOIL everything out first and then take the derivative, but I want to show how we can do this using product rule. So with product rule, we could treat our f of x as this first part, the 6x cubed minus x, and g of x as the second part, 10 minus 20x, okay? And here we have our general form for product rule. And having that in mind, all we have to do is really plug and chug and take a couple of simple derivatives. So f of x remains the same, 6x cubed minus x. Derivative of g prime, we have 10 here. We know that that is going to go to 0 when we take the derivative, since it's just a constant. And this part is minus 20x. We know the x is going to go away, and we'll just be left with minus 20 here for the derivative of g. And then adding f prime of x. For this first part, we have 6x cubed, so we use the power rule. We bring the 3 out and multiply it, so that's going to be 18. And then we subtract our power by 1, so we're left with 18x squared. And then we have minus x over here. We know that x is going to go away, and we're just going to be left with the minus 1. You could go ahead and multiply this out, simplify it, and make it look nicer. Oh, hold on. I did this too when I was practicing this question. I left out g of x. So g of x remains the same. We just multiply that to the end. That is my bad. Now that's our final answer. You could multiply this all out and make it simpler and nicer looking, but this gives us our h prime of x. And if we were just looking for like a specific slope at a point, then all you'd have to do is plug in x here. So answers should be accepted in this form. You don't have to simplify. So this is our second example. We have, in this case, we have h of x is equal to natural log of x over x. So for this, I want to show you how you can do this using quotient rule. So in this case, we would have f of x is equal to natural log of x, and g of x is equal to x. You could actually do this in such a way, if we rewrite it, something like 1 over x times natural log of x. If you wanted to do it that way, we could do it like product rule, actually, if you find product rule easier in general. But I want to show the quotient rule for this case. So I've went ahead and wrote down the equation for quotient rule. And again, it's just going to come down to plugging and chugging. And remember, low d high minus high d low over low squared, just to, if you need help remembering that ever. So let's go ahead and plug in. So g of x stays the same. Natural log of x, that derivative of that is just going to be 1 over x. Then we have minus f of x, so natural log of x remains there, times g prime of x, which is going to just be 1, over g of x squared, which is just x squared. Okay, we see that these are going to cross out, and we're just going to be left with 1 on this side. So we'll have 1 minus natural log of x times 1 is just natural log of x over x squared. There you go. That's it. Pretty simple.